So we're going to use trigonometric substitution to write an algebraic expression as a trigonometric function of theta. Okay, and we're in the first quadrant here. So if we're given this function of x, we want to substitute x for 5 plus sine of theta, and our goal is to write then our expression as a trigonometric function in terms of theta. Okay, so let's go ahead and first substitute x for 5 sine of x. Okay, so we get 25 minus, and so now I'm going to just replace x with 5 sine of x, or 5 sine of theta, and that's squared. All right, so let's go ahead and square 5 sine of theta. So we get 25 minus 5 squared is 25. Sine squared of theta is sine squared of theta. Okay, let's factor out a common factor of 25. So I can factor out 25. So 25 times what is 25 is 1, minus 25 times what is 25 sine squared of theta, which is going to be sine squared of theta. All right, and this should look familiar right here. This looks very familiar or similar to our Pythagorean identity. And so if I write that right here, let's see, my computer's kind of, let's see here. So if I write that right here, sine squared of x plus cosine squared of x equals 1. I want to rewrite this expression so that I have 1 minus sine squared of theta. So I can do that by subtracting sine squared of x from both sides. So I'm going to take this guy and put it over here. So I get cosine squared of x equals 1 minus sine squared of x. See, so if this is 1 minus sine squared of x, and this is 1 minus sine squared of x, and that's the same thing as cosine squared of x. So I'm going to replace this guy with cosine squared of x. So it's cosine squared, but I'm going to use theta though because we're trying to put this in theta. So now that we have a monomial, I can take the square root of 25, I can take the square root of 2. So that's just going to be 5 cosine theta. And that's that problem right there.